All right, let's dive in. We're going to talk about a programming language that, well, you probably don't hear about it much anymore. But what if I told you it secretly built the internet as we know it? And, get this, it even helped unlock the secrets of our own DNA. Yeah, today we're talking about Perl. And honestly, this quote right here, it's the perfect place to start. A Swiss Army chainsaw. Just think about that for a second. It sounds messy, right? Maybe a little dangerous, but also unbelievably powerful and versatile. And that one image, that single metaphor, it just nails the entire spirit of Perl. Let's dig into why. So, where does a tool like this even come from? Well, you might be surprised. Our story doesn't start in some Silicon Valley garage. Nope. It starts with a linguist who was just trying to deal with some really messy reports at NASA. Okay, so picture this. It's the late 80s. There's this guy, Larry Wall, and he's got this super annoying problem. He has to generate these reports from a bunch of scattered text files. And the tools he has, they're just awful, clunky, inefficient. So what does he do? Well, being a linguist, he thinks about language. And he doesn't just find a fix, he builds a whole new one. A brand new language made specifically to slice and dice text like a pro. And yep, that language was Perl. And the change was, wow, it was immediate. Think about it. Before Perl, you had this absolute mess of data. It was all manual, tedious work. But after Perl, suddenly you could automate the whole thing. You get these clean, organized reports. And maybe most importantly, it acted like this glue that could stick together all these different computer systems that couldn't talk to each other before. A total game changer. So you have this amazing ability to wrangle text and connect different systems. What comes next? Well, the next big thing, of course, the internet. This little utility built for NASA was about to become the unofficial duct tape of the early web. We're talking about the engine behind the very first versions of sites like Yahoo and Amazon. All those interactive things we just assume are there, Perl helped build them. So that begs the question, right? How did this, relatively obscure language just explode onto the scene and become one of the most important tools for building the entire World Wide Web? Well, it really came down to being the right tool at the exact right time. I mean, think about it. The web is just text, right? It's all HTML files, what you type into a form, server logs, and Perl was an absolute master of text. The other options at the time just couldn't keep up. C, way too complex and kind of risky from a security standpoint. There was TCL, but a lot of programmers found it awkward. And Python, the language that's everywhere today, it just hadn't hit its stride yet. So Perl was sitting there, ready to go. It was perfect. But, of course, no tool is perfect. And for Perl, its greatest strength, all that power and flexibility, was also its biggest weakness. On the one hand, yeah, it was free, it worked everywhere, and you could build stuff super fast with this huge library of code other people had already written. But that same flexibility meant it could be slower, and it could lead to code that was, let's just say, a total nightmare to read and fix later on. A real double-edged sword. And this whole idea of flexibility, it isn't just some feature. It's really the core philosophy of the entire language. To get Perl, you have to get the mindset behind it. And here it is, the official slogan. There's more than one way to do it. You'll even see it abbreviated as TimTowDDI. See, a lot of other languages try to force you into one right way of doing things. Perl, it does the opposite. It trusts you, the programmer. It says, hey, here are the tools, you figure out the best way to solve your problem. And this line of code shows that perfectly. Now, don't worry, this isn't a coding lesson. Just look at it. It's basically plain English, isn't it? Print this sentence. That's it. The whole language is built to be practical and to the point, especially with text. No fuss, no ceremony, just get the job done. So, how does this thing actually do all this powerful work? You might be surprised to hear that it all boils down to just 3 really simple building blocks. 3 basic ways to hold data. First up, you've got the scalar. That's the one with the $sign. A scalar is just one thing, a single item. It could be a number, or a word, or even a whole sentence. The sticky note analogy is perfect. It's one little note with one piece of info on it. Okay, next is the array, which uses that @ symbol. An array is just a list of those scalars we just talked about, and this is key, it's an ordered list. Your grocery list is a great example. You've got milk, then eggs, then bread. The order matters. That's an array. And finally, we have the hash with the percent sign. This one's a little different. It's a collection of pairs. So instead of a numbered list, you have labels for things. Think about a dictionary. You look up the key, which is the word, and you get the value, which is the definition. That's a hash. Simple as that. So let's put it all together. You've got the scalar, your single sticky note, the array, your ordered grocery list, and the hash, your dictionary. That's it. A single item, an ordered list, and a labeled collection. And with just these three simple ideas, Pearl can handle pretty much any kind of data you can imagine. All right, and now for the final chapter in our story. And this is where things get wild. This is where Pearl jumps from the digital world of the internet into the biological world of our own DNA. And I am not exaggerating when I say this. Pearl helped save the Human Genome Project. Seriously. Think about it. At this absolutely critical moment, scientists were being buried under this mountain of data, a completely unprecedented amount of information. They needed a tool that could handle it all. And that tool, believe it or not, was Pearl. I mean, it was a perfect match when you think about it. What is a genetic sequence? It's just a really, really, really long string of text, right? Just A's, T's, C's, and G's. And who's the master of text processing? Pearl. It just made sense. It became the go-to language for bioinformatics. Scientists loved it so much they even built special tools, like a module called Bioperl, just to make it even better for analyzing genes. And so this language, a language that started out just cleaning up reports at NASA and then went on to build the early web, it found its most incredible job yet. It became the #1 workhorse for an absolute revolution in biology. Just amazing. It really makes you think, doesn't it? Pearl's story just goes to show how the right tool, even a tool that seems a little messy or unconventional, can totally reshape entire industries. It really was the Swiss Army chainsaw for its time. So the question is, what are the chainsaws of today? What are the powerful, adaptable, maybe even kind of weird-looking tools that are quietly building our future right now?